Welcome to a quick revision of stereoisomerism. In the first part, we will see definitions and concepts. There are almost more than 20 definitions and related concepts in this chapter. Stereochemistry. The study of three-dimensional structure of molecules is called as stereochemistry. This is the first definition. Stereoisomers. Molecules with same molecular formula, same structure, but different arrangement of atoms or groups in space are called as stereoisomers. The example cited below is example of 2-bromobutane. If I number the chain as per IUPAC rules, this will be the first carbon. This is the second carbon. Third and fourth carbon are there in ethyl group. Similarly, on this molecule, the numbering will go like 1, 2, 3, and 4. These two structures have a mirror image relationship between them, and if you see the molecular formula is same. If you name them, the name will be coming as 2-bromobutane for this structure, and this will also be called as 2-bromobutane. When the name is same, it means the structure is also same. That is why we have this two terms, same molecular formula and same structure. But if you try to fit this molecule on this molecule, you will realize that all the groups are not coinciding. So they do have a three-dimensional difference between their arrangement of atoms and groups. So it makes them stereoisomers. The next definition is optical isomers. Optical isomers. The stereoisomers which rotate the plane of plane polarized light in equal and opposite directions are called as optical isomers. Enantiomer. The optical isomers which are non-superimposable mirror images of each other are called as enantiomers. Configurational isomers. The stereoisomers which cannot be interconverted by rotation of bonds are called as configurational isomers. Conformational isomers. The stereoisomers which can be interconverted by rotation of bonds are conformational isomers. We will just try to understand how these two structures are formed. These are eclipse and staggered form of ethane. We have this ethane structure where this particular front carbon is rotating, and when this carbon rotates, hydrogens are coming sometimes in the same line or they are going away from each other. And if we draw these changes, we get these two structures. These two structures belong to ethane and they can be interconverted by simply rotating one of the carbons. So because of this interconvertibility, they are called as conformational isomers. Chiral carbon or asymmetric carbon. Carbon attached to four different atoms or groups is called as chiral carbon. If you note this particular carbon, it is connected to four different atoms and groups. So this particular carbon is chiral carbon. Geometrical isomers. This is noted in alkenes. Cis and trans isomers formed due to restricted rotation of double bonds are called as geometrical isomers. Two possible structures where similar groups are on the same side of the double bond or similar groups are on the opposite side of the double bond, diastereomers. Stereoisomers, which are not mirror images of each other, are called as diastereomers in this example. And what you note is these two OH are on the same side of this vertical chain. And in the other structure, what you will find that on this vertical chain, the groups are on the opposite side. So there is no possibility of these two having a mirror image relationship between them, although they have got same molecular formula, same structure, but still they are different and they do not have mirror image relationship as well. So they are called as diastereomers. If there had been a mirror image relationship, you would have called these isomers as enantiomers. Yeah, mesocompound. A compound which is optically inactive despite the presence of chiral carbon atoms is called as mesocompound. If you look at this particular molecule, this carbon has four different atoms or groups, one, two, three, and this whole group can be considered as a group on this carbon. Similarly, this carbon is also having four different atoms or groups, H, CH3, OH, and this whole group is part of this carbon. So both the carbons are asymmetric in nature. However, if you see the molecule as a whole, then it can be divided into equal parts by imaginary plane. This part and this part is same. So the molecule is symmetrical, although it has got two asymmetrical carbons. Such molecule will be optically inactive. Such molecule will be optically inactive, and it is called as a mesocompound. Erythro and threoisomers. Okay. What we do first is take a molecule in the Fischer form, and again, if you note, these two carbons are asymmetric in nature. Chirality is there, and if you join in, you see this bond. Okay, uh, these two carbons are asymmetric, and this is the bond joining them. So in the definition, we see that in the Fischer projection, if like atoms or groups are on the same side of the bond joining the chiral carbons. This is the bond joining the chiral carbons. Like atoms are on the same side of this bond. So this kind of arrangement is now making this molecule as an erythro compound. Okay. The threoisomer will obviously have these like atoms on the opposite side. As you can see here, the OH groups are on the opposite side of the bond, which is joining the two asymmetric carbon atoms. Here is the definition. If like atoms or groups are on the opposite side of the bond joining the chiral carbons, the isomer is called as threoisomers. In the name, erythro and threo have been changed to erythros and threos because these two molecules belong to the sugar family. So their name is ending in two O's. DLN configuration. This nomenclature is given on the basis of the structure of enantiomers of glyceraldehyde as the standard compound. And what we do usually is draw a structure in the Fischer form, and we find out the lowermost asymmetric carbon atom. And on that carbon atom, if the heteroatom or group is on the right hand side, the molecule is called as D. And if the heteroatom is on the left hand side of the lowermost asymmetric carbon atom, the structure is called as L structure. Absolute configuration. It is the description of spatial arrangement of atoms or groups on the chiral carbon in terms of R and S notations. And we rotate arrow starting from 1, then we go to 2, and then we go to the third group. Arrow is rotating in the clockwise direction, so we call this as R2-bromobutane. This is a theoretical method of identifying the isomers. Optical activity. Property of rotating the plane of plane polarized light in clockwise or anti-clockwise direction is called as optical activity. Optically active compound. The compound which rotates the plane of plane polarized light in clockwise or anti-clockwise direction is called as optically active compound. Plane polarized light is the light which is vibrating in single plane. Dextrorotatory compound, the compound which rotates the plane of plane polarized light in clockwise direction is called as dextrorotatory compound. Example, you can take any asymmetrical structure and put a small d or dextrose. Levorotatory compound, the compound which rotates the PPL in anti-clockwise direction is called as levorotatory compound. You put small l in front of the name of a symmetrical compound. Racemic mixture. This mixture is optically inactive because it is a mixture of two enantiomers in equal proportions. So rotation caused by one isomer is cancelled by the other isomer. Mixture of, for example, mixture of D and L lactic acid is a racemic mixture. It is designated as DL lactic acid. Specific rotation. Rotation of plane polarized light shown by optically active compound in a certain condition. What is that condition? When its concentration is 1 gram per ml and the path length of polarimeter is 1 decimeter, that is 10 centimeter. The formula of specific rotation can be given as alpha 20D is equal to observed optical rotation by the given compound divided by concentration of that compound into length of the polarimeter. So here we complete our first part, which is based on definitions and basic concepts. In the second part we will go for stereochemistry of cyclohexane.